So I told you we're going to do an exercise on dynamic programming, but I haven't told you yet what dynamic programming is. And there's some history about why it's called dynamic programming, and it has to do with funding because the word dynamic is like, ooh, people, it's just exciting. But anyway, there's some history on that. But basically, what dynamic programming is a way to answer a big problem by breaking it down into sub-problems. And then the overall solution is the solution for each sub-problem. So like your big problem is my house is dirty. Oh my gosh, it's overwhelming. So let's break it down by clean the bathroom, clean the kitchen, do whatever. And then when you add all those small solutions, your overall solution comes about, right? So I don't know. Maybe this cleaning the house is not a very good example for me, but I guess it's too close to home right now. um, so what is dynamic programming? That's what I just told you. It's a way to address a problem that is too big by looking at the whole problem. So we break it down into smaller problems, and the overall solution is the summation of the solutions of the sub-problems. Why we use dynamic programming to align sequences? And the answer to that is that if you did every possible alignment to sequences, that would take too much computational time, and actually it's not tractable. You would have so many combinations that you couldn't align every single possibility, which would be called the naive method. And then these are, so the algorithm is a set of unambiguous instructions. So the computer can't make decisions like which one you like better. It just has to be like, when this happens, you do this. So and then a bunch of instructions like that is an algorithm. And then which algorithm? What I'm really asking here is, what is the name of the guys that came up with the algorithm for local? And what's the name of the guys that came up with the algorithm for global? This is like the easiest points for this next exam. You just pull up this slide and then you'll see. I'm just asking who wrote the instructions for local, who wrote the instructions for global. Since they do slightly different things, there's a difference in the instructions between them. Okay, I already told you the algorithm is the unambiguous instructions. And okay, so these guys, Smith Waterman, they came up with the instructions for local, and this Needleman, and I can't say this guy's name, Wunsch, I don't know. They did for the global. And you're going to compare the alignment using this algorithm versus this to see what is the tweak that allowed the global to may allow you to do local. So they're very similar with very small changes, and which then allows you to compare just blocks of similarity versus comparing the overall similarity. And this part here, be able to build the score matrix, that's the exercise. The trace back is actually the summation of the solutions of the sub-problems. And okay, then you're going to calculate the score of the alignment, which is how many points you add when you do the trace back. So do one more slide. So here, when I said something about smaller problems, the small problem here is what's the score of T and T? The other small problem is what's the score for substitution between T and H? The other subproblem, so each of these cells on this matrix is a subproblem, okay? And then the summation of the best solutions for each subproblem, which are these guys here, is called a traceback. So each of these, or each square is going to have a little score, and then you're going to add the high scores for each of them, which will normally be in a diagonal. So this is where we're going to pick up on Wednesday.